Okay, so welcome to this video on 10.4 continued. The last video was titled 10.3, 10.4. We got a little bit into 10.4 yesterday. We talked about some different things with negative exponents and zero exponents. This is really just meant to be a review. I want you to look at these problems and think about what's going to happen. So we're subtracting exponents. We're subtracting 7 top minus bottom, 7 minus 4. So 9 to the 7 minus 4 is 9 to the third power. So that's the answer to 1, okay? That's the answer to 1. So once we've got that answer, we have 2 is 4.2 to the 6, 4.2 to the 5th. Well, if we do 4.2 to the 6 minus 5, we have 4.2 to the first power. We don't really have to write the first power, but we can. We can. So you look at the last couple questions and you think to yourself, maybe I could answer those on my own. So I'd encourage you to pause the video and try to answer 3 and 4 on your own. So pause the video and give those problems a shot. So hopefully those came out fine and you got some solid answers for those and you found them to be not too difficult. So what I'm going to do now is I'm going to move on to a couple of different problems that maybe are a little bit more advanced. There's like two things going on at once in these problems. So it says simplify the expression, write your answer as a power. So if I look at this for a second and I simplify the bottom of this, I have 2 to the 3 and 5 is 8. So I have 2 to the 8th. The top doesn't change. I have 2 to the 15th. So this is going to be 2 to the 15th, 2 to the 8th. I'm going to subtract exponents. 15 minus 8. That's the division rule of exponents. And that's 7. So 2 to the 7th is our answer for 5. So hopefully that makes some sense. And you could take a second to try number 6. Don't worry about number 7 right now. But try number 6 as a now you try. So I'm just trying to show you simplify the top, simplify the bottom, and then simplify the fraction by the division rule. Also, when you're multiplying fractions in number 6, I'll have a little rhyme. Multiplying fractions, no big problem. Top times top, bottom times bottom. So that would be a good thing to try. So pause the video and give number 6 a try. So as you're doing this multiplying fractions, top times top, bottom times bottom, whenever you're multiplying exponents, whenever you're multiplying powers, the big rule when you're multiplying, right, is to keep the base, and to add the exponents, the little guys. Okay, add the exponents. So as I do that here on the top, I get d to the 5 plus 9, so that's to the 14th power. Now, everybody know if there's no exponent, it's an invisible 1. So it's to the 9th on the bottom. So pause the video, give that a try. I think I will tell you the answer to it as well. Okay? Yes? So d to the 5th power should be the answer to that problem. Okay? So let's go on to some different things. So before we move on, I just want to make one more point. I just want to point this out one more time, that when you have an exponent, when you have no exponent, it's to the first power automatically. So I put this little 1 in here for that reason, right about here. Okay? So watch out for that. So that's kind of your basics. That's your building blocks. And now I want to talk a little bit about something we did yesterday. We looked at this pattern of 2 to different powers. And it's probably important to just try this with something different than 2. So I'll ask for a second if we could think about 4 to different powers, 4 to a few different powers. I'm going to try 4 to the, I guess I'll try a few different things here. Let me see if I can get a little more space. So 4 to the, I think here I'll put 4 to the 0, 1, 2, 3. And here I'll put -1 and -2 because we're going to go down. So if you look at right here, okay, if you follow these numbers right here, right, all of these numbers right here, and you follow that pattern, right, as you go down, you're just subtracting 1 from every single thing. 3, 2, 1, 0, -1, -2. So what we want to do is just know the answers to these. So I'll start with one that I think is pretty simple. 4 to the 2nd power is 16. And now if I times that by 4, right, if I multiply that by 4, I could have 64. So I think what's happening is 64 divided by 4 is 16. 16 divided by 4 is 4 to the first power, which is 4, right? And now we want to know what 4 to the 0 power is. Hopefully we're starting to understand that 4 divided by 4 is 1, so anything to the 0 power is 1. Now I'm going to make a pretty important case here, is that when I divide this 1 by 4, I'm going to get what? What is 1 divided by 4? 1 divided by 4 is 1/4. Now this 4, I know there's a million 4s on the screen right now, but this 4 is actually this 4. These are coming from the same place. And if that's the case, go up a level, right? And think about what 4 to the negative 2 is. Does somebody know what 4 to the negative 2 is? Exactly. So 1/4 divided by 4, 1/4 divided by 4, well that's 1/4 multiplied by the reciprocal. That's 1/16, right? So this is going to be 1/16. We divide 1/4 by 4, then we have 16 pieces of pizza if that's the case. Here's the deal though, this 16 right here is actually this 16. So do you think you could tell me what 4 to the negative 3 would be? What would 4 to the negative 3 be based on this pattern? Look at the green inner shell, then the red, and think about what happened with the 64. So 4 to the negative 3 would be, yes? Yep. Yes, 1/64 would be 4 to the negative 3. So according to this pattern, we'd take this and divide it. What are you noticing? Something to the positive 3 power is 64. Something to the negative 3 power is 1/64. So in a sense, you're going to push things to the bottom of a fraction. That's not a very technical term, but that's kind of what's happening here. So let's move on. We know that anything to the 0 power is 1. Because if we do this table out with any number, this table here, no matter what we do, every single time, this middle section right here is going to come out to 1. So we know that 0, any number to 0 power, except for 0 that is, will come out to 0. So if it's 5 to the 0, if it's negative 2 to the 0, if it's a million to the 0, if it's a half to the 0, it doesn't matter. Negative, positive, it always comes out as 1. So let's look at these problems here. A couple of different things going on here. And hopefully you're understanding so far. So let's try a couple of these. So when we go through these problems, it gets a little weird because there's multiple ways to do the problem. I'm not going to lie to you. There's more than one way to do this problem. But I like to first think about it like this. 3 to the 6 divided by 3 to the 6 is the same thing divided by itself. If it's the same thing divided by itself, it's going to be 1. And also, like, I could do this 3 to the 6 minus 6. I could subtract the exponents and get 3 to the 0. But 1 is really the simplified version of that. Anything to the 0 power is 1. So it's divided by itself, it's 1. How about this one? 7 to the 0 and 7 to the second. Well, that's 7 to the 0 plus 2, right? Which is just 7 to the 2. Agree? So it's almost like this guy right here was useless. And the reason that is because that's equal to 1. It's 1 times 7 to the second. It's just 7 to the second. So the answer is 7 to the second. So anything to the 0 power is 1. You could just rewrite it as a 1, and then you just have 7 to the second. So it might be a good idea to pause the video and try this problem, and perhaps try this problem, 3 and 5. Pause the video and give those problems a shot. So I want to say something about number 3, just to clarify. What we're doing here is we're taking the base, which is negative 2, right? And we're bringing it to the power of 6 minus 6. We're subtracting the exponents. But we know that 6 minus 6 is 0. So it's negative 2 to the 0 power. And negative 2 to the 0 power follows the rule that anything to the 0 power is 1. And also, I mean, you know that these are the same, top and bottom, so we know it equals 1 anyways. So that's how you get the answer to 3. The answer to 5 is 9 to the third. Hopefully you got that. We are continuing on. So I want to make a couple of points here that are pretty important. In whatever this is saying that 0 exponents, anything to a 0 exponent, except for 0, because that's not a real thing. It's undefined. This is something that they try to cover in like higher up math. Anything to the 0 power is 0. But here's a really important thing. This is a pretty important thing to understand right here. Here is an example. This is an example. And this is every time. This is every time, or this is the rule. Okay, so I'm going to give you the rule and I'm going to give you the example. So I want you to get this. If you take one thing away from this, aside from what we reviewed, it's going to be this example and this rule. If I tell you I want 3 to the negative 4th power, what will you write that as without an exponent that's negative? If it's 3 to the 4th power, it's going to be the negative exponent moves to the denominator, and that's going to be 3 to the 4th, but it's going to be a 1 on top. Okay? The reason that there's a 1 on top is a placeholder. So we know that it's going to move to the denominator, and there has to be something on top of a fraction. This is not a thing. You can't have this. You have to have a number there, whether it's a 1, whether it's a 4, whether it's a 14. You can't have a fraction that has nothing on top unless you put a 0 there. But if you did put a 0 there, then that whole fraction would come out to 0 anyways. So it'd be kind of useless. So this is the big understanding, and what we want to do is just kind of rewrite a couple of these to understand that before we wrap this up. So 3 to the negative 4th is 1 over 3 to the 4th. What is 2 to the negative 3rd? It's 1 over 2 to the 3rd. What is 5 to the negative 2? It's 1 over 5 to the 2. I changed the exponent from negative to positive, moving it into the denominator of the fraction. That is the big takeaway. So it might be a wise choice to try a couple problems, perhaps try this problem, or maybe a couple of these. So what I would have you do is pause the video and try 1, 3, and 5. If those come out good, then you know you're in pretty good shape. I'm going to wrap it up there, so I will see you in the next video. But now you try 1, 3, and 5. Peace.